In this video, we want to take a look at exponential growth. Now, exponential growth is a consistent percent of change from one data point to the next. Previously, we looked at linear growth, which was a consistent amount of change from one to the next. We increase by 5 each time, or we decrease by 200 each time, but the amount stayed the same. Now, when we graphed it was a line. Here we're changing by a percent of what the previous one was, and that might change the amount. So let's take a look at an example. We have started our own business and have a plan to grow sales by 10% each month. If you sold $100 of product initially, how do you calculate P sub 1 and P sub 2? Well, our formula has been recursively start with the initial P sub 0, 100, and then change that. So P sub 1 is going to be the 100 plus, we're increasing, plus 10% of that 100. So to calculate a percent of, we multiply. 10% changed to a decimal is 0.10, so that's why I have the 0.10 times 100 here. When I simplify that, I get 110. Okay, so how do I come up with P sub 2? I have to use what I just calculated and add 10% to that. So I'm going to start with the 110 and add 10% of the 110. Right? It's always of the one right before it. So in this case, we're going to come up with 121. Now, what's really interesting, I think, is that you notice we have a $10 change from initial to the first month, but then from the first to the second month, we're changing by $11. So even though I'm keeping the percent of change the same, the amount is going to vary. Well, that's not a big deal off. What would happen if we looked out a little further? Well, I went ahead and calculated for up to 10 months after, and I've plotted them here on my scatter plot and drew a line through there. It's a pretty consistent, a little above, a little below, but it's overall pretty close. But what if I wanted to go out even further? If I calculated it out all the way to 30 months, I would see that that linear pattern suddenly changes and is not going to be very reliable, because all of a sudden the amounts changing between each data point is going to be significantly more. So as I go here at the original, there's very slight difference, $10 to $11 to maybe, $12.50 or something. But then when I come out here, there are going to be big jumps from one month to the other if I'm taking 10%, because I'm taking 10% of a larger number. All right, so what would the equation look like? What would the formula look like? Well, we're going to use our recursive pattern and look for that pattern. All right, so use the recursive formula to come up with a pattern. P sub 0, the initial, is 100. P sub 1, we took 100 plus 0.10 times the 100. Now, instead of actually simplifying it as it is, I'm going to look at that and say, well, wait a minute, there's 100 in common here. Let's factor that out and then simplify inside and recognize that what I have for P sub 1 is 100 times the quantity of 1.10. Okay? P sub 2. Well, you take the one right before it, P sub 1, and add 10% of that. So P sub 1 plus 0.10 times P sub 1. That is similar to what we had above, so I'm going to factor out that P sub 1, and I'm going to have P sub 1 times that quantity, 1 plus 0.10, which can be simplified, and I'm going to replace this P sub 1 by what we have right above here, and say that's 100 times 1.10, that's my P sub 1, times the next 1.10. Well, if you have two factors that are the same multiplied together, the more efficient way to write that is squared. So P sub 2, it turns out, is the 100 times the 1.10 squared. Okay, so that exponent matches this. Up here I have an exponent of 1, matches the subscript over here. Let's see if the pattern holds for P sub 3. P sub 3 is going to be P sub 2 plus 10% of P sub 2. You've got the pattern, right? We're going to factor out the P sub 2, and we're going to come up with another 1.10 there when we simplify inside the parentheses, and we're going to replace the P sub 2 by what we have right above here. And I have 100 times 1.10 squared times another 1.10. So if I have a square times another one, adding those together, we get 1.10 cubed, or to the third power. So it really is true that in general, P sub n is going to be equal to the 100, the initial value, times 1.10 raised to the n power. So this inside here is like my growth multiplier. It involves the growth rate. We'll talk about that a little bit more in the next video.